All right, so in this video, what we're going to focus on is how does the graph of a parabola change? How does the graph of a quadratic change when I change the values of A and C? So we're not going to focus on B. B is a little bit more complicated, but we at least want to see how things change when I take this A value here, this number in front of x squared, and I change it. If I increase it or decrease it or make it negative or positive, what does that do to the parabola? And then the same thing with C. How does that change it? So I have a list of what those changes are. For example, I'm letting you know here that when A is bigger than 1, when I start increasing it, making it larger and larger and larger, the graph is actually going to get really, really skinny. It's going to narrow. When I take it and make it a number between 0 and 1, which another way of saying 0 and 1 is a fraction or a decimal, things like half or 0.2 or 1/10, those would be numbers between 0 and 1. If the A value looks like that, the graph's going to get wider and wider and wider. As we get closer and closer to 0, the graph will get wider and wider. Okay, the negative values don't make it any wider, but what they do is they flip it over the x-axis, and then my C value really just takes the whole thing and slide it up and down. Okay, so seeing this list probably doesn't mean a whole lot, so let's take a look at what actually happens. Okay, so here's my a graph of y is equal to x squared. This is the regular, simplest graph we could get. We call this a parent function. Okay? And you can see off to the left here I have these little sliders, and this is basically saying A is 1 right now, so it's 1x squared. C is 0, so this is actually not really there. So if you see what happens when I start changing x, if I start taking this slider and I start making it bigger and bigger and bigger, now you can see that the graph is actually staying exactly where it is, but it's getting narrower, it's getting skinnier and skinnier, and I can keep going. I'm only going to go up to 10, and you can see it's pretty narrow at that point compared to what we started with way back here. Oops, too far. Okay, right back here, I would say that's pretty wide, and right, this is a lot skinnier. So when I make A really large, my graph gets skinnier. Okay, and the second bullet on that list said if I start making it things like fractions and decimals, it gets small, it gets wider and wider. So here's like a tenth. You can see how that's way wider than my original graph. Right, so these fractions and decimals in the A spot make the parabola get really wide. Okay. Now, the negative values kind of get a lot of people because they might think, oh, well, a negative is even smaller than 0.1, so that should get even wider. What that ends up doing is it actually just flips it over. So if I take a look at -1, right, and I compare that to +1 in the A spot, you can see it's the exact same parabola, but just flipped over the x-axis. So the negative doesn't really make it wider or narrower. The negative just makes it flipped over version of the positive, right? So you can see these are getting narrower and wider. Okay, so let's make our A value, let's say 4. Okay, so if I leave that alone and I start adjusting the C and I say let's make the C value bigger, you can see what this is actually doing is it's taking my graph and it's just moving it up. And if I make it a negative C, it's taking the entire thing and it's just sliding it down. So C value just takes the whole thing and pushes it up or pushes it down. A makes it wide, narrow, and maybe it might do something like this and flip it over. And so you can see that these values really just take that same parabola shape and they slide them around the graph. Okay? So if we come back here, if I ask a simple question of you and I say, take these 4 parabolas and let's put them in order from widest graph to narrowest graph. Right, we're going to look at these A values and say the widest graph is going to come from the smallest number or the number closest to 0. So I'd say this one right here is 1/4, and that's smaller than 4, and it's smaller than 1. So I'd say 1/4 x squared, 1/4 x squared would be the widest graph. Okay, a 1 would be the next widest graph, or the next narrowest graph, and then -4 actually has the largest number, even though it's got a negative sign. Remember, the negative is just going to make it upside down. But the number's the largest, so I'm going to say that one's going to be the narrowest graph, right? So we can kind of look at the actual function and just have a picture in our head that this one's going to be the narrowest or the widest graph, okay? And I can also look at problems like this and I can say, how are these graphs different? And I'm just going to do a quick sketch. I'm not going to actually plug in and get all the points, but I would say y is equal to x squared looks something like this, right? It kind of comes out of the origin. Oops. Messed up my graph a little bit. Okay, it comes out of the origin and it makes this U-shaped graph. Okay, y is equal to x squared plus 3. I can say, well, wait a second, these things are the same except I just increased my C value, right? This was plus 0, and I increased it all the way up to 3. So what that's really going to do is it's going to take the vertex and it's going to say, well, instead of being at 0, 0, let's move it up exactly 3 units. So it's going to be the exact same graph, okay, except it's going to be exactly 3 units up. So it just does a slide. So if I were to compare the domains and the ranges, remember the domain last time we said for parabolas was actually all real numbers, and that's actually always going to be the case. I can plug whatever I want into these functions, and I'm always going to get something back. So whenever they ask you about the domain of a quadratic, you're going to say it's everything. You can always plug in everything. But the range in this case, my original one, we saw one before, I'd say this stops at this imaginary line here, and it won't go below that, which we said was y is greater than or equal to 0. Right? It's everything above 0. When I change that c value, now it's moved up higher, and I'd say my imaginary line where this vertex is actually now here. So the range is different now. Instead of being at y is greater than or equal to 0, it's y is greater than or equal to 3. Okay? So you can see that these values actually change the way that the parabola looks. It slides them up, slides it down, wider and narrower, and it gives you a picture in your head of what these graphs should look like.